Today, we are just be practicing everything we've done the past 4 days with logarithms. So we're going to be converting in and out of logarithmic form and exponential. We're going to be evaluating logarithms. We're going to be describing transformations, and condensing and expanding logarithms is going to be the main focus of today. So I want you guys to do 1 through 10, take 5 to 10 minutes, pause the video, and it deals with everything we've been doing the past 4 days. So looking at number 1, we're writing this equation in logarithmic form. So we're taking it out of exponential form and writing it in logarithmic form. The logarithm, so let's start with log. The base on our exponential is the same as the base on our logarithm, so that'd be log base 1 over 2. And a logarithm is the inverse operation of an exponential, so it's always going to equal the exponent, which is -7 in this case. And our argument, that's the word I'm looking for, is d. It goes right there. So number 2, we're taking the equation out of logarithmic form and putting it in exponential form. Remember natural log? What's the base on the natural log? It's e. So if I'm putting this exponential form, our base is e. Our exponent is what the logarithm's equal to, is x, and our argument is 15. So now we're going to evaluate each expression. So let's take a look at number 3, or if it's an equation, solve for x. So 3 is an expression. It does not have an equal sign. So I want to figure out what log base 2 of 32 is first. So what is the exponent that would go on our base of 2 to get a 32? So overall inside, I'm going to say 2 to the x power equals 32. I'm going to think about it. Well, that would be 5. So it would be 5. And then minus 10 times log of 10. Log of 10, remember, log is just really base 10 if there's no base written there. So log base 10 of 10 is equal to 1. So that would be 10 times 1. And if you're thinking, if you forgot about that property, that's fine. Just go off to the side, and it would be, if I do log base 10 of 10, that's the exponent on 10 to get 10. So that exponent is going to be 1. So that's why log base 10 of 10 is 1. So that would be 5 minus 10, which simplifies to -5. Number 4, that is an equation, another common log, so the base is 10. So let's take this out of logarithmic form and put it in exponential form. That would be our base is 10, our exponent is 2, our argument is 4x. 10 squared is 100. Equals 4x, divide both sides by 4, you would get x equal to 25. E is an expression, so e to the ln, remember, inverse operations, they cancel out, so we're left with 9x here, minus log base 6 of 1, whenever 1's the argument, our exponent's 0, because that's saying what exponent goes with 6, our base, to equal 1. Anything to the 0 power is 1. And then the last part, ln and e are inverses. So we can cancel those out, and we're just left with plus log of 1 over 100. What would log of 1 over 100 be? Well, remember the base is 10 on the common log, and we're flipping it to go to 1 over 100, so I have to be negative. How do I get from 10 to 100? You square 10, so log of 1 over 100 would be -2, so it would be 9x minus 0 minus 2, which just simplifies to 9x minus 2. Number 6, we have an equation. Let's take it out of logarithmic form and put it in exponential form. So my base is 8. My exponent is 3. And that's going to be equal to 2x plus 100. Our argument, 8 to the 3rd. Feel free to put this in your calculator. That is 512 equals 2x plus 100. We're just going to solve it from there. Subtract 100 on both sides. And then divide by 2. And you're going to get x to equal 206 for your final answer. I'm going to make that a little bit neater there. X and x equals 206. So now let's describe how each function is transforming from its parent function. So the parent function for both of these would be f of x equals ln of x. So look at number 7. That is getting shifted, that minus 7 on the inside with the x, that is getting translated right 7 units. And up 10 units. We look at 8. Well, first off, that minus on the that negative on the outside means we're getting reflected over the x-axis, and that plus 1 means we are and shifted or translated. I'm going to say translated. Translated. Plus 1 means we're going to the left 1 unit. So for 9 and 10, number 9, let's completely condense these logarithms. So I want to write these 3 logs, if I can, try and get them to 1 log. So my first step here, I see they all have coefficients, so I'm going to bring those coefficients and put them as exponents. So that would be log of x. The 1/2 is just going to make it a square root plus log y to the 3rd minus log z to the 5th. Now I'm going to combine. So when I'm adding logs to the same base, we can multiply the arguments and transform them into 1 log. And when we're subtracting, we can divide the arguments. So if you want to go step by step, go right ahead. I'm going to do that, but you can do this all in one step if you want to. So the first 2 would be log of radical x times y to the 3rd minus log z to the 5th. And then when you subtract, you're dividing. So this would simplify to log of radical x times y to the 3rd all over z to the 5th. And the last one, number 10, we're going to completely expand this logarithm we write it as more than 1 logarithm. The first thing I would do here is, if you notice, the entire argument is getting cube rooted. So I'm going to rewrite that as an exponent. So that would be ln of 4a squared over b to the 4th to the 1/3. So now I'm going to bring, since that entire argument's being raised to the 1/3 power, I'm going to bring that out as the coefficient. So now it would be 1/3 ln of 4a squared divided by b to the 4th. Okay. So we have a product in the numerator of the argument, and b to the 4th is in the denominator of the argument. So when we're multiplying, we can separate them into 2 logarithms that are being added, and when we're dividing, we can subtract. So this would be 1/3 ln, oops, let me put this parentheses there, 4 plus ln of a squared minus ln b to the 4th. So I'm rewriting that 1 logarithm right now as 3 separate logarithms. So from here, I'm going to bring out each of those. Let me write that 4 a little neater for you guys. I'm going to bring out each of those exponents. So this would be 1 over 3 times ln of 4 stays ln of 4. I can bring that 2 out for 2 ln of a minus 4 ln of b. And now the very last step, make sure you multiply that 1/3 into every single thing in every single logarithm in those parentheses. I make this mistake sometimes, so make sure you distribute that to every single term in the parentheses. So that would be 1/3 ln of 4 plus 2/3 ln of a minus 4/3 ln of b. Make sure you check your work and you're not making a simple mistake like not distributing that throughout all the terms in the parentheses. So that's it. What I want you guys to do, the rest is just practice. It really leads you through the entire unit so far, logarithms. And that's it. There's some challenge questions at the end. And that's it.